What caused matter to exist at all? Before atoms, before stars, before even time as we understand it, how did the first elements emerge from a universe that was just beginning to expand and cool? This is Mattermosaic, piecing together the universe, one discovery at a time. Today, we explore how the first elements formed in the earliest moments of cosmic history, and what physics can and cannot yet explain about the origin of matter. According to current cosmological evidence, the observable universe began about 13.8 billion years ago in an extremely hot, dense state. This model does not describe a creation from nothing in a simple sense. It describes the evolution of the universe from the earliest moment our physics can meaningfully describe. At that stage, energy and matter were interchangeable, as expressed in the equation developed by Albert Einstein, E equals mc squared. In the first tiny fraction of a second, the universe expanded and cooled rapidly. During this period, fundamental particles formed from high-energy radiation. Quarks combined to create protons and neutrons within the first microseconds. The universe was still far too hot for stable atomic nuclei. Any attempt at binding particles together was immediately undone by energetic photons. About 1 second after expansion began, temperatures dropped enough for the ratio of neutrons to protons to stabilize. Weak nuclear interactions froze out, leaving roughly 1 neutron for every 6 protons. This ratio would determine the chemical future of the cosmos. Around 3 minutes after the beginning, temperatures fell to about 1 billion degrees Celsius. Now, nuclear fusion could occur. Protons and neutrons fused into deuterium. Deuterium rapidly combined into helium-4. Small amounts of helium-3 and lithium-7 also formed. This brief era, lasting less than 20 minutes, is known as Big Bang nucleosynthesis. In the 1940s, George Gamow, Ralph Alpher, and Robert Herman calculated that this early process would leave the universe composed of about 75% hydrogen and 25% helium by mass. Modern astronomical observations confirm these predictions. The discovery of the cosmic microwave background radiation in 1965 by Arno, Penzias, and Robert Wilson provided further confirmation of this hot early phase. After about 20 minutes, the universe became too cool and diffuse for further fusion. Heavier elements could not yet form. For hundreds of thousands of years, matter remained a hot plasma of nuclei and free electrons. Only about 380,000 years later did temperatures drop enough for electrons to combine with nuclei, forming the first neutral atoms. Light was finally able to travel freely across space. The first elements were simple: hydrogen, helium, and traces of lithium. Everything heavier, carbon, oxygen, iron, was forged much later inside stars and supernova explosions. Science can describe how the first elements formed from the early hot state. The deeper question of why that state existed, or whether time itself had a beginning, remains an open frontier in cosmology and philosophy. What we know with confidence is that within minutes, the universe established the chemical foundation for everything that would follow. Every hydrogen atom in your body traces back to those first moments. This is Mattermosaic, piecing together the universe, one discovery at a time. If this journey to the earliest measurable chapter of cosmic history changed how you see the matter around you, share it with someone curious about our origins, and let us know which cosmic mystery we should explore next.